Hello, if you've recently been to our open source repository in the OpenSuspect GitHub page and you checked out our wiki for developers, you might have seen these pretty graphs. So these graphs are part of our documentation effort so that we can avoid having code that we don't understand. And so these are control flow graphs that depict how certain things in the game are implemented. They show function calls from one file to another and how, because this is a multiplayer game, how some functions are calling other functions on the server, and then how the server is calling back the client, and how the server is distributing the data for other clients, and so on and so forth. And you can see that this graph is kind of complicated, so no one really wants to make it by hand. And so in this video, I will be talking about how I automated making this type of control flow graphs, or at least part of making these graphs using a Python script with a lot of Python magic actually, and also Graphviz. So we are on Linux, and Linux follows the Unix philosophy in a lot of respects. And the most important part of the Unix philosophy is to have maybe simple command line tools that take input from the standard input, some kind of the text stream, and then output something to the standard input. And this is what Graphviz is doing. And I first heard of this from the always great Coding Daily YouTube channel and Twitch channel, where the host used Graphviz for a very similar purpose to demonstrate the control flow of some simple and some less simple programs that he was writing in his own programming language. And so to check out the Graphviz capabilities, you can check the gallery part on their website, and you can, for example, click on this graph, and this will show you how this is implemented in Graphviz. So what you do is you have to write this kind of it has its own descriptive language. It's very simple. So you define kind of the clusters, you define the style, some kind of the styles, you define what's connected to what, and you can add some further connections, and basically that's it. Graphviz will generate the image. You can generate PNGs, you can generate SVGs, which is my preferred way. PNGs can just get really big and really difficult to view, but SVGs, you can even select text and things like that. So Graphviz is a very nice tool to make the graphical representation. What you have to do is you have to create this description, this text that describes the graph somehow, and this is where the Python magic comes in. So for my script, I use the whole directory. So in Godot, what you have is you have a project folder which contains all these different .gd files, and each GD file represents a separate class, and they have functions and they can call each other. And so what I do is I try to process the functions and create these very simple and easy to understand blocks of it. Well, first you have to check, let's check this join game function, for example, in main menu.gd. And what it does, it gets the data from the UI, and then if there is a port given, then this custom port will be used. Otherwise, nothing will happen, of course. An empty host or player name will be rejected. So, and then join a game, and then this part join a game will actually just call the other function, the join game function in connections.gd, and that will initialize Godot networking and save data in globals. So similar things you can see here, like checks menu, and there are these three options. So this one will tell you that kind of in the menu check you have three options, or here you can see that for all players create a character. So this demonstrates kind of a loop structure, and so both loops and conditionals are displayed in this way. So, and then, well, if there is just the linear structure of this function, then it will just have all these blocks below each other. And so what it does, what you have to check here is that to describe the functions, I use these comments, and these comments have not just the first hash that, or double cross, or what is this symbol called, pound symbol, someone calls it. and it has a second one. This will tell my Python script that this is kind of a descriptive comment that will describe all these 4 lines that come after it. So I'm not going to put all these 4 lines one by one on my graph. That would be very confusing. Instead, I'll just put this one comment, like this initialize Godot networking. This description went here. And the similar thing is with the if structures, for example. In the main menu function, we have all these lines that will just get the data from the UI. So that's just one descriptive line. And if port is given, describes this conditional. And then whatever happens when the condition is fulfilled, then this custom port is used. That's these 2 lines. And for example, here we also have a conditional one, but we don't describe what's inside the conditional because it's very simple. We can describe the whole thing just by this one line, so we don't need to go in here. And you can see that this on the graph is just simply displayed as one full line. Alright, so how do we do this in Python? Well, with a lot of Python magic, of course. So I have this graph.drawer.py script that is doing the hard work here, and I already have it opened. And well, what we have here is we can find files using this find files. Find files function, what this will do is it will take a path, and this will just walk through recursively in this path, and we'll find all the .gd files and return this file list. And we use this file list somewhere down here in this read all function. It will just gather the list of the files. And then we'll go through all the files and we'll process those files. And the process files is where a lot of this magic is going to happen. So today's video, I'm just going to go through this, how we process the files, and the drawing of the graph specifically will be discussed in a later video. So today we are just going to, this is a lot of Python magic in this, so bear with me. This will be enough for one tutorial just to analyze what's happening here. So let me start IPython for demonstration purposes here, and I can load the graph-drawer.py here. And let's start with this simple find files command. So we will find files, and then my files are in home/nicemicro bin open suspect.src, I think. No? Oh, opensus. It's just opensus. What I was thinking there. Alright, so this one will give you all the files in it's an array, and the array contains the directory name and the file name. So this is one of our files. And there is in this src game character GD, and then all of these files are here. So this found all the GD files in our project directory, and we can use this other function, the process file function, to go through one of them. So I think for first, let's do the main menu.gd maybe. So I can do process_file. Is this the name? Yes. And then I'll give it the path of home/nicemicro/bin/opensus/src. And then inside this we have UI_elements. And then in this we have main menu.gd. And we need 2 more parameters here. One is going to be this. This is the marker, so this is a hash and the space. And we just need to give 1 hash because this Python script already knows that in Godot the comments are started with a hash. So, and we can only have these descriptions inside comments, of course. So we have to give an additional hash and a space to start that kind of descriptive comment. And then false will be the 3rd parameter, because if this is kind of the 3rd parameter, the show all parameter. If I give true here, that will, every line will be shown in the graph. But those, so for example, this get data from UI, this comment will only be applied to this one line, and then all these other lines will be just shown as is in the program. If I give true here, so that's why I gave false, you can see this returned what seems to be a dictionary. So let me just do the same thing, but let me put it in a variable that's called a, and then I can do a.keys. So this is a dictionary, and the keys of the dictionary are here the function names. So you can find, for example, join game, create game, and join event. These are all functions in our main menu .gd file. And so we can, of course, check out the description of one function here. If I say a join event, for example, you can see it contains the type of this function. This is a place.universal. So there could be, this script can handle 3 types of functions. It can be universal, server, or client, but I don't really use this anymore. So I made this because first I was thinking I would just put all the functions on the control flow graph, and in the server I only want the functions that the server is using to be there. But then I decided that, well, I will just only show the functions that are taking part in one certain control flow. So I don't really need to specify which is the server function, because if something is not a server function, I will just not use it in my server block, so it won't be shown up anyways. But the script itself, it can handle that, and it will differentiate based on this kind of, you should have the 2 hashes, and then dash dash, and then server there. So I think if I go back to the connections here, it should have like this, something like this, but with 2 hashes in the beginning. That would be kind of delimiter, and everything that comes after this delimiter would get a place.client, or if everything goes after the server, place.server would be, and this dictionary contains another element, which is the control. So we can just, reference it like that, and that control is a list, and this is a list of the things that are happening in the function. And it seems to me that this is one big list inside a list. So this list, this control list, it contains only one element, and that element is a list. And that element contains check menu. There is an empty list inside it. Then there is join game, create game, and dedicated server. So this is how we represent the join event function, which you can see there is one big thing here, which is, this is a conditional, so match is a conditional, and inside this we have 4 things. So this one is not, there is no descriptive comment for this part, so that's what became this empty list. Well, this list is not empty. The list contains an empty string. And then we have join the game, so that's one element, and then create game, that's another, and then dedicated server, that's a third. And these are the 3 string elements in that list. If I go and just check join game here, the join game is one list, and the list contains a string, contains another list, and contains a string. So this one is the join game from connections. You can see that this became a string element. So this whole function became the list. This first part became a string in the list. Then, what is this? No, I'm sorry. This is the join game. I was looking at the wrong join game function. This is the join game function. I'm looking at that. So this became one string, get data from UI. You can see here. Then this part became something else. This one became another list. If port is given, custom port is used. And then this is displayed on the graph this way. So this is you can see that this whole function is a list. And then inside that list, there is another list. And that's how my graph generator will know that this should be placed next to each other. And this is that. And then we also have another list. This is a list, but it contains only one string because there is nothing inside this conditional that would be put after this string. So this is just a list with only one string in it. And then we also have this join game, which is another string that came from this part. All right, so how is it done? Well, process file is a complicated function, and as I just said, it contains a lot of Python magic. So how is this magical thing done? Well, one of the most important thing is the functions, which will contain all the functions. So this will be a dictionary where the key is the name of the function and the element is like, the connection or not the current type, like universal or server or client, etc. And the control. So this will be the dictionary with all the functions in it, and the control will be the part of that. The control list will be the part of that. We are also counting the tabulators because Godot is, or the GDScript language is similar to Python. Well, Python I think uses like the 4 spaces as indentation, but Godot, like GDScript, we use the tabulator characters for indentation, and we need to count them because how I know that I'm outside of this if block is that, well, I had 2 tabulators, but now I only have 1, so I must be outside of that block, and things like that. So that's why we need the tabs. And then we also keep track of the comments because we want to keep these descriptive comments and we want to put them into our graphs. So these are kind of the main things. And this is where the Python magic will happen, is this function control list. So first of all, we open the file, of course, and read it line by line. And we will split these lines by the hash character, which is the standard comment character for GDScript. So this is hard-coded here, kind of. And everything left to this hash symbol will be the command, and everything right to the hash symbol will be comment. So commands and comments. And we want to check the comment line. From the comment line, we remove the comment marker, and then we check whether this is an accepted comment, and the accepted comment would mean that, I guess it contains the marker that we set up. So the marker can be like an empty string, and then every comment will be accepted. We can also just replace white spaces with tabs or tabs with white spaces, and that should still be accepted. And then if it's an accepted comment, then we just add the comment line will become the comment without the marker. So we remove the comment marker, and then we remove the marker that we use for the accepted comment, or the kind of the description comment that we want to use. Otherwise, comment line is empty. And we also use this strip function from Python to remove all the leading and trailing white spaces, because we don't need the white spaces in the beginning and the end. Here is how we calculate the number of the tabulators. I guess we check whether we have kind of the server or client delineators, and we'll change the current type of the function, whether it's client or server. And then next we check whether we have a keyword that denotes a start of a function. So remote function, puppet function, master function, remote sync, etc. These are kind of the markers that GDScript can mark a function with, and we are looking for these, and we are looking for line. So what we did is we separated the f line, which is the line in the file, to just line, and the comment line, and the line is, of course, what is the command? What are the commands in that line? It's maybe it's not the best name for this variable, but that's what it is. And if it's a start of a function, then we will initialize the things that are looking for what's in a function or trying to describe the function. So we will basically save the we'll create the function name. Function name is always right to the keyword func and whitespace, and it is always, I guess, left from this first parenthesis. So, for example, here, join game, this function name is the right from the keyword func, and then left from the first parenthesis. So that's what we do there. And then what else do we do? We create this new element in the functions dictionary, but with the name of the function name, and it will contain the type and the control. The control will become this empty list, and the function control, which is going to be the Python magic, as I already told you. The function control will be a list, and this list will contain the function's current function control. What is function's current function control? So this is actually this empty list. And if you remember if you have seen and remember my video on the weirdest thing in Python, you will know that this will be not just another empty list. This will be the exact same empty list that's in here for control. We are also counting the tabulators and then zero the comments. So the comment would be empty from now because we just started a new function. So let's clean the comment and let's continue. So all these comments, all these part of the function will not be executed there. We will just go to the next line in this for loop here. So this is how we start a function. And I would like to demonstrate how things go on in the next part. So for that, let's initialize our mock function. So instead of this all complicated thing, I will let me clear the screen. So we will have a function variable, and let's make functions a dictionary, and we only will have this control element in that this element will be an empty list. So now we have funcs and there is a control in it, and then we want the function control variable, which will be a list that contains the funcs control. And now f underscore c is a list that contains an empty list. So we have these two variables set up for our demonstration of how the following parts are done. So this part, it will just check whether our current tab depth is lower than the previous, so whether we are outside of the kind of the indentation that we were in. So of course, if we have an empty line, I don't know how this handles empty lines, but I think it should just ignore empty lines, so they shouldn't confuse the program that, oh, we just found an empty line, and in an empty line there are always less tabulators than in the previous one. If it's not, then I should handle that. I have not run into this bug, but anyways, that's not important. That should be handled, and even if it's not handled, it should be. So next thing is, well, we will add the current comment line to the comment, and bear in mind that we always start with a new line character. So even if we zeroed the comment last time, we will start with a new line character. So there's something that we need to consider in the later parts. And then the next thing is going to be ignore lines, the ones that are not tabulated deeper than the last function declaration. Yeah, so I guess if something seemingly outside of the function, that should be ignored. Yeah, so empty lines will be ignored here. All right. And then we check whether something is a control item. So I call control items things that start new control blocks like conditionals and loops. And in GDScript, just like in Python, they always end with a colon. So you check whether the last element of the line is a colon. That's why we need to strip the white spaces from left and right, so we can check whether the last element is a colon. And so basically, if it's a control item, we want to create those elements like this. We need to create a new list, and we put them in a list, whatever is inside that control block. And by control block, I mean like this indented parts of the if statements or loops and whatever. And that will be achieved by this part. So first, let's check what happens if it's not a control item. So if it's not a control item, just a regular comment. So we are going to do it because this is the simpler thing we need to do. And so if the comment is empty, so there was no comment before this command, but we turned on the show all parameter, then it will just append whatever line is in the function. So for example, this line would go in there. But if the show all is not turned on, then nothing will happen if the comment is empty. But if it's not empty, we just put in the comment. So this is how, for example, this get data from UI will get into our graph here. And what happens is basically we append this to the last element of the function control. So we do not put anything directly in the functions dictionary. So where we put it is always in the function control and always the last element of the function control. So this function control, you might think it looks a little like a stack. Well, and what I'm going to show you is real Python magic, and I came up with it myself. I did not copy this from anywhere. I did it by myself after watching, I don't know, 20 hours of Coding Daily on YouTube. So take a look at it like that. I am very, very satisfied with myself here. All right. So what happens if I add this line, add the new line? So let's just emulate what happens in this line, and we go to the function controls last element and do an append. And what do we append here? We just append just a simple string. So this is a string that's going to be appended here. So let's add a 1, for example. And then if I just print you fc, then you can see now we contain, so this has been added to the last element of fc, and last element of fc was a list. And now that list, there was an empty list, now that list contains a1. But what happened to the functions? So you can see, because this list, this empty list, is not copied from here, it is the same list as this one. So now it also contains a1. And this is the same what happens here, because this function control list that's actually linked, or at least the last element of that function control list is actually linked. Where is it? It's here. So it's actually linked. It's actually the same as this control element of whatever is here. So we are not accessing this directly. We always access it through the function control. And so if I append another line there, that's exactly going to be the same. So I append this to the last element of the function control, which is still the same thing there, same list. So if I do that, my function control just, the same list, or, well, it still has one list, but the list in the function control contains these two elements, and then my functions will just have this in it. The control element will contain A1 and A2. All right, so I think this is clear. So let's clear the screen, and let's see what happens if I have a control item, such as an if statement or a loop. What we do is, instead of adding the string itself to the last element of function control, we actually append the list, one list that contains the string. So it's a new list that contains the string is appended there. So if I do this, then let's make it B1, and that should be in a list. So once I did that, if I check my function control and my functions, and so nothing out of the ordinary happened here. We just put in a list instead of a string. But what's the magical thing is that now, after we did this, so after we appended whatever we wanted into the function control's last element as a list, now we append to function control the last element of function control's last element. So let me just put it in here in my whatever this is, fc.append, and we append to the function control variable directly the last element of the last element of the function control variable. So fc minus 1 and then minus 1. So before I do that, let's think about what is the last element of the last element of the function control. So last element of function control is this list, and its last element is this list, and that's what I append. So once I did that, my function control list became longer. So now it contains one element which was there previously and then another element. This of course have no effect on our function dictionary, as you can see here. It's unchanged. This only affected function control because I did not manipulate any of the things inside function control. I manipulated function control itself. And let me remind you that I came up with this myself. All right. So jokes aside, what happens next is that, let's say we are in this if statement like here, and then we have a new thing to add inside this if statement. So the next thing we will run into is going to be just a regular command. So what we do is what we did before, f underscore c dot append. No, sorry, we need to add this to fc minus 1 dot append. That's what will happen, and then this will, right? Yes, and this will be b2. So this is going to be just something very regular. So regular command, we just append to the last element the string itself. So to the last element we append the string itself. All right, so what happened to fc? We can see that we added it to the last element. So last element was this list, and this got added with this b2. But you can see that this list is the same as this list, so it contains b2 now. And if I print you my functions, you can see this is the real magic here, that now I added this b2 into this list that's inside the list. So we've got into there. So if it's clear, then let's clear the screen and let's check what happens if we are outside of that. So our current tab depth is lower than the previous, so which means that we are outside of this if block. So we are back to our regular function block here. What will happen is we just pop the last element of function control. So what does that mean? fc.pop will just pop the last element, and then let's see what's left. And this is what's left in fc. So our last element is now this again. And if I recheck our functions, that's, nothing happened there. So if now I happen to add something new to my function control, let's see, C1, for example, that will be added to the last element of function control, which is, last element is this list. So it will be added after this element of the list. Can you see what's going to happen? Can you predict what's going to happen? This is what happened, and the functions, this is the same thing. And this will work with nested ifs and nested loops. And how this would work with nested things is that we need to add to fc minus 1 dot append, but we will append a list there. Let's make it d1. And then after this, how is it done? So after we append this, we also append function control dot append function control minus 1 minus 1. So let's do that. Function control dot append the same thing. And now function control looks like this. Now, of course, no one's surprised that now this last element is got there. So we have, this is the first element of function control, this is the second element. What if inside this if statement, I have another if statement? So I have to append E1, for example, to fc minus 1. And then I also have to do the same thing. This fc.append one more time. And now my function control looks like this. So you can see we have one element, which is basically the whole thing. The second element is the current, or is the next, is inside so this is like the if block inside the function that is here. And then we have this element, which is also here and here. So if now we have a new command added, that's going to be fc -1.append, and it's going to be just a simple, like maybe make it e2. It's just a simple command. It's not a new control block. So now how things look like is, let me just show you function first. So what what was the name of this variable? Damn it, funcs. All right, very good variable. I already forget its name. So you can see this is our control. This is a control list. And in the end, we have this list inside it, and then inside that another list. And so, of course, if we get outside of that, what we do is fc.pop, I think. That's what we do first. And then if we add another element to fc, maybe d2, then our function will have this d2 outside here. So you can see this is kind of how it's implemented. And if we want to get outside of this control element and just add the function after this, then we have to pop again. So this is how the multiple levels of nested ifs and nested loops are handled. So we will get a list, and for each nested if or nested conditional or loop, there will be another list in the list which will contain the commands inside. So this one first will be, actually it's not just the commands inside that nested loop, because for the graphing purposes, I want them to be on the same level. So even though in the program itself, in the function, in the programming language itself, you know, the if statement is on the same level as this one. But because in the graph, I want this if statement to be right next to my thing, then what I will do here is just put them on the same level inside my variable. So this is, for example, the if statement. The conditions, we describe what the conditions are, and then what happens if this condition is met. And of course, if we have multiple lines, we could have implemented it in a different way, but I found this was the simplest way, because otherwise, if I wanted to put the if statement right here, and then whatever inside the if statement into a list, then it would have been, you know, I would have to keep track of how those things are happening. I found it much more simple, and I can just, use the graphing part of my program to create this. And, like in this join event, we have this checks menu, and it has the join game and create game and dedicated server parts inside this conditional. This is a match statement, and you can see that these are now below each other, but in general, these four would be in the same list. So these will be the four elements of the same list, but because it's a control item, my graphing part of the script just knows that the first one goes to the left and all the others go to the right. And, if there is nothing inside the if statement, like in this case, we don't have anything described inside the if statement, then my graphing, this will be just a list with one element, and this is how it's going to be displayed there. Alright, so I told you that just talk about this first part will be enough for one tutorial. So in our next video, we are going to check out how the graphs are parsed and how they are displayed. And maybe the third part of the tutorial, I don't know if it will be 2 parts or 3 parts, I will actually show you how to use it. But first I wanted to go through exactly how it's implemented, because I think it's much more interesting than actually how to use it. And also because it is a very specific tool, so I don't really think that anyone actually needs to use a tool like this. It's much more interesting to understand how to create tools like this. But in any case, maybe in a video I will show you how a graph like this is made for OpenSuspect. And maybe if you happen to be working in Godot and you happen to need a tool like this, then I will show you how you can use mine. And I guess this is the end of the video, so I guess it's time to show my socials where you can find me, and you should follow me, and you should subscribe to all of my stuff. And let's just show it again. You should also give me money on Patreon if you have any money left in these kind of situations or whenever. But I will see you in the next one. Leave a comment down below if you find anything interesting about this. And of course, if you want to argue with me in how I implemented this, you can also do that down there. Give me a thumbs up, like this video, whatever. Share it with your friends who are interested in programming. I was Nice Micro, and I am out.